G'day and welcome back to Mathematics for another HSC maths lesson. Today I'm going to take you through my lesson on integration by substitution in the Extension 1 HSC course. Just filling in some gaps in my Extension 1 playlist. So if you're an Extension 1 student looking for more content, please subscribe and I'm going to put up some more videos throughout the year. So let's get into it. Starting off with the first example for integration by substitution, we have the integral of x divided by 2x squared minus 1 squared, and we are going to try and simplify this integral, make it easier to achieve by using the substitution u equals 2x squared minus 1. So our goal with these questions is to try and translate this integral from an integral involving x into an integral involving u in the hopes that will make it a bit simpler. Now in Extension 1, the substitution will always be given to you, so you don't need to figure that part out. You just got to know how to work with it. So obviously in our integral, where we see a 2x squared minus 1, we're going to change that to a u, but the issue is we're going to change everything else. So we're going to start off with the dx. We need to try and figure out a way to turn this into a du. So we're going to start off with our substitution, u equals 2x squared minus 1. And now if we do the derivative of u with respect to x, which is du on dx, differentiating this, we get 2 times 2x, which is 4x, and the 1 differentiates to 0. So here is our substitution differentiated. Now our goal is to rearrange this into an expression for dx that we can sub into our integral. So the way we're going to achieve that is we are going to multiply the dx across to the right hand side, and we'll also divide the 4x across the left. So these two are going to kind of swap places. So we end up with du over 4x on the left hand side, and on the right the dx is multiplied across to now be by itself. Okay, so now we have an expression that we can change dx into du on 4x, so we can change that here. In the bottom of our fraction, we can instead write this as u squared. So subbing that in and seeing what happens. Now there's still an x on top, the bottom is u squared, and our dx is du on 4x. Now this question's been designed to work out pretty conveniently because there is an x on the top and bottom of these fractions, so we can sort of simplify and vanish these away. While we're doing that, we can move the 4 out the front, so we end up with a quarter outside of 1 over u squared du, and now we have an integral that is only involving u's, and it's much simpler than when we started, and so now we can go ahead and do some integration. Okay, so to integrate 1 over u squared, we need to use a negative index. We're going to write this as u to the power of minus 2, and now we're ready to go ahead with our reverse power rule for integrals. So make a bit of space. And up here, we're going to still have the quarter out the front. We are going to raise the power by 1 to become u to the minus 1. Now we divide by the new power, and because we have an indefinite integral without limits, we need to have a plus c on the end. If you forget the plus c, you got to do 10 push-ups. That's the rule. Okay, now we're going to simplify this, and to finish it off, we're going to sub back in the fact that u is equal to 2x squared minus 1. So with questions like these, you have to make sure you back substitute if you want to get full marks. So simplifying this a little bit, I'm going to pull the negative out the front, and I'm going to write u to the minus 1 as 1 over u. Still got the plus c, and now, like I said, changing u back to where we started to be 2x squared minus 1. We have our final answer of 1 over 4, 2x squared minus 1 with a negative out the front. If you're feeling a bit fancy, you are welcome to expand the bottom. You can put the negative on the top if you want, but either of these two last lines are going to get you full marks, and they're considered to be equivalent, so whichever one you prefer really. And that's it for example 1. So sub in your u, change your dx, and then fix up the rest, and then proceed with your simple integral, nice and easy. Okay, let's have a look at another example where we do have limits involved, and I'll show you how to handle those. Okay, so for example 2, our substitution is u equals x squared plus 4. Here's our integral, and our limits are 0 and 1. Okay, just like last time, we need to figure out a substitution for dx. So we'll start off there by starting with our substitution of u equals x squared plus 4. And we'll once again do du on dx. So the differentiating the right hand side turns into 2x. And now we'll do the same rearrangement we did in example 1, where the dx will multiply across to the right and the 2x will divide across to the left. So we have du on 2x equals dx. And now that's our substitution for dx. Okay, now on our integral, we have two limits of 0 and 1, and these two numbers here are actually x values. So if we are translating the integral, we need to turn these two x values into u values. So the way we're going to do that is we're going to go to our substitution, and we're going to sub in x equals 0 and sub in x equals 1 and see what we get for u values. So u is equal to 0 squared plus 4, which is just 4. So the 0 at the bottom is going to turn into a 4. And the 1 at the top, 1 squared plus 4 is equal to 5. So our top limit is going to be equal to 5. Okay, so now going back to our integral, let's chuck everything in and see what happens. So on the bottom, inside the square root, we have x squared plus 4, which is going to become u. And our dx is going to become a du on 2x. So making those changes with our new limits of 4 and 5. Okay, now once again, question has been generously designed because we have an x on the top and an x on the bottom. Those two are going to simplify away. We can put the half out the front. And because we're going to want to integrate 1 over the square root of u, we can put that into index form. So writing u as a power of a half, writing the square root of u as a power of a half, and then bringing it up top by making it negative. So this is, the x is simplified, the half out the front, and then writing 1 over root u as u to the power of minus 1/2. Okay, now we can do some integration. So power rule once again, we're going to add 1 to our power, so now it becomes a half, and we're going to divide by the new power of a half. Okay, now even more convenience going on, we have a half multiplying out the front and a half dividing on the bottom. So these two are going to simplify and magically cancel each other out. And u to the power of a half is of course equal to the square root of u. So making a bit of space, we now have the halves cancelled out and we're subbing in 5 and 4 into the square root of u. So we sub in 5 first and we get the square root of 5. We sub in 4 next and we get the square root of 4. Square root of 4 is equal to 2, so our final exact answer would be the square root of 5 minus 2 for our integral. Okay, so we need to fix our dx, we need to fix our limits, and then we sub in and then see what else is left to deal with. Okay, so those were two nicer examples that sort of tied it up really conveniently. Let's look at a couple of questions where it's not so convenient and there's still a little bit of more work to be done to simplify and tidy up before we proceed. All right, on to example 3. This one's another indefinite integral with no limits, and our substitution is u equal to 1 minus x. Okay, so like with the last two examples, we're going to start off by fixing up our dx. So starting with our substitution of u equals 1 minus x, taking the derivative of both sides, the left-hand side will become du on dx, and the right-hand side differentiates to minus 1. Okay, now we'll push the dx across to the right. We can divide the negative 1 by both sides, and so we can make the left negative because we want to try and get dx by itself. So multiplying dx across, swapping the negative across, we have dx equal to negative du. Okay, now let's chuck some stuff in and see what happens. So our dx is becoming negative du. Inside of our square roots, we have now the square root of u. And the problem now is that we still have an x in our expression that is not simplified away. So we need to translate this by going back to our substitution and getting an expression for x in terms of u that we can substitute in and then proceed. So back to our substitution, which is u equals 1 minus x. We're going to rearrange this to make x a subject, which is pretty easy. We can just add the x across to the left-hand side and minus the u across to the right-hand side. So we get x equal to 1 minus u. So going back to our integral, the x is now going to become a 1 minus u multiplied by the square root of u, and then we have the negative du on the end. Okay, so with that negative, we're just going to yoink that out the front so we don't have to worry about it. And we're going to have to expand our brackets here so we have two things that we can integrate. So expanding out, we get the square root of u times 1 minus the square root of u times u. Like I said, the negative's out the front and we'll worry about that later. Okay, so to apply some integration, we're going to have to write everything in index form. So we have a power of a half for the square roots. We have u, which is actually u to the 1, and that's multiplying another square root, which is a power of a half. So when we add these two together, when we multiply these two together, the powers are going to add together and give us 3 over 2. So our next step is to make this u to the power of a half. So again, that one there, adding the powers becomes 3 over 2. Okay, now we have them in index form. Now we can start doing some integration by adding 1 to the power and dividing by the new power. So negative is still out the front. We have a new power of 3 over 2, so we're dividing by 3 over 2. For the second expression, we've increased 3 over 2 by 1 to be 5 over 2, and then divided by 5 over 2. Don't forget your plus c, or it's 10 push-ups. Proof in the comments, please. Okay, so when you are dividing by a fraction, a cool little trick you can use is that the very lowest denominator, which in this case is the two 2's, these can actually flip up the top and join the u's. So the very bottom of your lower fraction flips up the top. So we have a 2 on the top now and a 2 on the top now. Expanding it out, our first term is negative and our second term is now positive because we have negative, negative. Okay, now we're going to turn these back into surd form and then back substitute the fact that u is actually equal to 1 minus x. The question was in terms of x, so we need our answer to be in terms of x if we want to achieve full marks. So a power of 3 over 2, that's going to be the square root cubed. So the bottom power is the root and the top power is the power. So we have the square root to the power of 3. I've just flipped the order here. Sorry, that's confusing. The positive term has gone at the front and the negative term is in the middle now. I just think it looks a little bit better, but it is completely optional. Okay, so the 3 over 2, we have the square root cubed on here. And then for the power of 5 over 2, we have the square root to the power of 5. So that's putting them into surd form, flipping them around. And still got the plus c, and now putting in that u is equal to 1 minus x, we get 1 minus x to the 5 in our first expression, and 1 minus x to the 3 in our second expression. And that right there is our final full marks answer, back in terms of x with the plus c and all your surds. Okay, let's have a look at another example like this where there's a little bit more work to be done, but we'll do another one with some limits for a bit of practice. So example 4 is pretty similar. We're integrating between 3 and 4. We have x times the square root of x minus 3, and our substitution is x minus 3. Okay, let's start off once again with our du on dx. So, we're going to start with our limits just to mix things up. So turning our two x values of 3 and 4 into u values using the substitution. So first one is u equals 3 minus 3, which is 0. So the bottom number is going to become 0 now. And for the top one, we have u equals 4 minus 3, putting into the substitution. So our top number is turning into a 1. So our limits now are going to be between 0 and 1. Now we can fix the du on dx. This one's really nice because when you differentiate both sides with respect to x, you get du on dx equals 1. And so we multiply the dx across and we just get du equals dx. It's a nice clean conversion. Okay, when we put that in, we'll have a u inside the square root. We'll have the dx becoming a du, but we'll have the same problem as last time where there's still an x out the front and we're going to need to fix it. So to fix it, we'll go back to our substitution and we'll once again rearrange this to make x the subject. So we have u equals x minus 3. We're just going to add the 3 across the left-hand side. So we get x equal to u plus 3. Now we have all our substitutions ready. Our limits are becoming 0 and 1. Our dx is becoming du. Our square root is going to become square root of u. And the x is becoming u plus 3. So now we're at a familiar place similar to last time. We have a expression multiplied by the square root of u. So we just need to expand everything out. So we have u times root u, and we have 3 times root u here, and we have 0 and 1. Okay, so putting this into index form, once again, just like last time in example 3, u to the 1 times u to the half will become u to the 3 over 2, and we have 3 times the square root of u, which is 3u to the half. Now we have everything in index form. We're ready to do some actual integrating and get towards our answer. So let's make a bit of space, do a fancy little green arrow. Okay. Adding 1 to the powers and then dividing by the new powers once again. Familiar story, we end up with a 5 over 2 for our first power, dividing by 5 over 2. We end up with a 3 over 2 for our second power, dividing by 3 over 2. Still have our limits of 0 and 1. Okay, we can simplify a little bit. Similar tricks to last time. The 2's on the very bottom are going to flip up to the top. We'll have a 5 here, and luckily this 3 here is going to cancel this 3 out the front because we have a times and a divide. So these 3's are going to go. So we have 2/5. If you want, we're just going to put it into a calculator, but you can just put them into surd form if you want. We have the power of 5 over 2, once again being the square root with the 5th power, and we have the power of 3 over 2 being the square root of the 3rd power. Okay, now we can chuck in some numbers. So when we chuck in 1, luckily 1 to the power of anything is always 1. So the square root of 1 to the 5 is just 1, and the square root of 1 to the 3 is just 1. Also very convenient, when you sub in 0, we're just going to get zeros everywhere because we get a 0 here and we get a 0 here. So the substitution into our limits is very nice and neat. We get 2/5 plus 2 for the first expression with the 1's, and then for the second expression, we just get zeros everywhere. So I'm just writing minus 0 to make my working out nice and clear. Okay, now we can just finish it off and do 2 out of 5 plus 10 out of 5 and get 12 out of 5 for our final answer for example 4. Alrighty, cool. If that's making sense and you're keen to try a couple by yourself, here are a couple of easier examples for you to sink your teeth into that all work out pretty nice. So by all means, pause the video and have a crack at these. I'm not going to run through the solutions because they're pretty repetitive, but there are online integral calculators where you can check your answers, or even better, you can post your answers in the comment and I'll gladly let you know if you're on the money or if you need to make any adjustments. So yeah, let me know. We're going to finish off by looking at a couple of HSC questions, one on the easier side, one on the more spicy side. Starting off with this first one from 2008, which was a whopping 17 years ago. Back then it was a band 4. These days probably a bit closer to a band 3 potentially. Pretty much in every year of the HSC there is at least one integration by substitution question, and they're usually 3 marks, sometimes 4 marks if they're a really spicy one, as we've been seeing more of recently. Anyway, let's dive into this one. Our substitution is u equals log base e of x, and reminder that's another way of writing ln x. Our limits are e and e squared. Here's our integral, and we have a dx. All right, let's fire off by fixing up our limits. Let's substitute e and e squared into our substitution for x and see what we get for u. Okay, when we sub in e, we get log base e of e, and that's just equal to 1 because e to the power of 1 is equal to e, and you can just put that into a calculator. For log e squared, again, the log base e and the e are going to cancel out, and it's going to leave us with 2 as our answer. Once again, you can check with the calculator if you're not really sure. Okay, so our limits are changing from e and e squared to 1 and 2. Let's now fix up our dx. So we'll go to our substitution, which is u equals ln x. We'll differentiate both sides, so we get du on dx equals 1 over x, which is the derivative of log x. Okay, rearranging to make dx a subject, we are going to cross multiply. The dx is going to go across to the right, and the x is going to go across to the left. So we get x du equals dx, and now we have a substitution for dx. Okay, let's chuck it all in. So now our integral looks like this. Our limits, are 1 and 2. Our dx has become an x du, and our fraction has become 1 over x times u squared. So log base e of x is the u. Again, like I said, this one's pretty friendly because if you set it up correctly, the 2 x's are just going to simplify and vanish away, and so we end up with 1 over u squared, which we're going to write as u to the power of minus 2, just like in example 1. Okay, now it's all tidied up, everything's in terms of u's, and we can go ahead and do some integrating. So we are going to add 1 to the power to become minus 1, divide by the new power of minus 1, and evaluate between 2 and 1. If you like, before you substitute in your values, you can simplify. I'm going to do that. I'm going to pull the negative out the front, and I'm going to write this as 1 over u to the 1. And now I've got something really easy I can substitute into. So still keeping the negative out the front, and I'm subbing in 2 for the first value, and then subbing in 1 for the second value, and then taking the difference. So evaluating this, we get a half minus 1, which is negative a half. And so we have negative a half, which gives us a final answer of a half. So if you got the same thing and you paused and tried yourself, congratulations on your 3 marks. You're doing really well. Let's try and keep that momentum into the next one, which is a bit more recent and a bit more tough. This is from 2014. In that year, it was a band 5, which is like an E3 level in extension 1. Okay, we have the integral between 2 and 5 of x over the square root of x minus 1. Our substitution is x equals u squared minus 1. Okay, so this is the main reason why this question is a little bit challenging. It's because it feels like our substitution is backwards. Normally the question gives us u equals something in terms of x. This time we have x in terms of u. But ignoring that, our process is going to be very similar. You just got to be careful where you are chucking stuff. If we start off with our limits, keep in mind that 2 and 5 are x values. So if we're putting them into our substitution, they're going to be going on the left. So starting off with the 2 equals u squared plus 1. We don't need any fancy algebra here. We can just solve this by inspection. Clearly, u squared needs to be 1 to make the left-hand side match the right-hand side. And so if u squared is equal to 1, u is equal to 1. I know that u equals negative 1 also works for this equation, but we don't really need it. We only need 2 numbers for our limits, so we'll just stick with the positive ones to make our life a little bit easier. Fixing up our second limit, which is 5, we have 5 on the left-hand side, so 5 equals u squared plus 1. Solving this gives us u squared needs to be 4, which solves to u equal to 2. So changing our 2 limits from 2 and 5 to 1 and 2. Now let's figure out our du and dx relationship. So we have our substitution, x equals u squared plus 1. Now we're going to differentiate both sides in terms of u. So the left-hand side will become dx on du, and the right-hand side will be 2u plus 1. So I think this is the best way to approach this. I know some people like to rearrange this to make u the subject, but I don't think that's going to make your life any easier. I would recommend doing it this way. Okay, so now we just multiply the du across the right-hand side, and we have dx equals 2u du, and that is our expression to chuck into our integral for dx. Okay, so let's sub everything in. On the top and bottom where we see an x, we're going to replace them with a u squared plus 1, and now it looks like this. Our new limits of 1 and 2, our top is now u squared plus 1, our bottom is the square root of u squared plus 1 minus 1, and our dx is 2u du. Okay, now let's try and do some simplifying. So on the bottom, the plus 1 and the minus 1 are going to cancel each other out, and then we'll have the square root of u squared. And the squared and the square root cancel each other out, so the bottom just turns into u. Okay? That's really convenient because now there's a u on the bottom and there's a u on the top, and so these two can cancel out and then they're gone. And while we're at it, let's just chuck this 2 out the front to make our lives easier. So we have 2 outside of the integral between 1 and 2 of u squared plus 1. Nice and simple integral ready to go. If you get this far, the rest of the question is very simple. Let's rip into it. Let's use our power rule. U squared integrating to u cubed on 3, 1 integrating to u, and now we have our limits of 2 and 1, and I'm just keeping the 2 out the front, but not forgetting about it. Okay, so subbing in our values now. If we sub in 2, we get 2 cubed over 3 plus 2. If we sub in 1, we get 1 cubed over 3 and a 1, but because they are the second limit, I'm just subtracting them, just trying to do it all in one step to get through this. Okay, and then we can just chuck this all into a calculator, but we can simplify it a little bit first. We've got 8 over 3 plus 2, minus 1 over 3 minus 1. This is going to simplify down to 20 over 3 as your final answer. So again, if you try this by yourself before I ruined it, and you got 20 out of 3, congrats on your 3 marks in what was historically a pretty tough question. So you're doing really well. So yeah, when the substitution is given to you backwards, you do not need to rearrange. You can just proceed like this, and it becomes much easier to manage. Okay, if you got that done, well done. Thank you for making it to the end of the video. I appreciate your attention. And if you are looking for some more Extension 1 content, please subscribe because there's going to be heaps more. Plenty on the channel already, but there's more coming this year to get you ready for your HSC. So yeah, thanks for watching. Like, comment, share, all that good stuff. And see you soon for a new lesson. Peace out.